Fancy meet computers. How is everybody today? Dead. I see. Ha. That's not the many people. There's not the many people in my class today. You guys have a midterm or something? Maybe. Maybe you do, maybe you don't. Nobody's saying anything. No midterm, just death. Okay. Still crying over 2QA4. Well, look on the bright side. It's currently Thursday, which means that in a few days it will be Friday. By which I mean one day. Just nobody goes to the class before lecture, so they probably overslept. Yeah, maybe. That's entirely possible. Man, 8:30 classes are the worst. But 9:30 classes, come on. You ain't got no excuse. I know undergraduates will, like, sleep in till 1 in the morning, but the lecture before this is very questionable. Well, now you've just piqued my interest. What is it, and why is it questionable? Is it because you actually have questions, or is it, like, of questionable utility? In a few days, everything you've been putting off is due. Quick, can you help me program my way out of calculus? No, unfortunately, I'm only teaching you discrete math on this in this course, not continuous math. So, Friday and weekend we got to work on a log lab. Ugh. Of questionable value. Yeah. So, so what is the class though? You haven't told me what the class is. Ah, the people who arrived later have a greater likelihood of being smiley face, probably because they got more sleep than the rest of you. Ah, okay. 2QA4. Dynamics. Yeah. Yeah, I don't know. I don't know what the problem is. Like, I guess it'll depend on the professor. When I took it, it was like one of the more fun courses I took that semester, actually. Yeah. All I will say is, instead of writing equations, he teaches a subject. As he teaches a subject, he erases an opaque highlighter that he puts on top. Wow. It's like statics, except we aren't told what to do. It really shows us his thought process, you know? Oof. Yeah, it's kind of interesting. It's like my personal philosophy on how to teach on an online platform. It's like kind of to try to not make use of the platform to save myself work, you know, because any way that I use the fact I'm on a computer to try to save myself work versus like an in-person lecture is going to be like definitely picked up on by the students as being laziness specifically, and basically, you know, if the professor cannot be bothered to actually, you know, put some effort into teaching, then why should you put some effort into learning? Well, because of the exam. So, you know, it's kind of setting you up for failure, but yeah. We got marks off for solving a question with a different method, and it didn't say which method we had to use. Oof. See, I always think that if you get it right, you get it right, you know? It shouldn't matter what method you use, unless the method is called for specifically in the question. That's the one exception, right? Like, if it says, use this method, then if you don't use that method, then that's what because you're being marked on using that method, obviously. But yeah, if there's no method that's been specified, you know, like, for this class, if I expect you to use recursion to solve a question, I will tell you, I expect you to use recursion to solve a question. Because otherwise, you know, you're just setting people up for failure. Yeah. Lost 25%. Oof. You wish I taught every course? Ah. Well, I wish I taught every course too, but I can only manage 3 per semester. So, yeah. What you should do is you should lobby the department to get me on more mechatronics courses. That's what you should do. There was actually a possibility this semester that I would be teaching 3TA4, which is your embedded systems course that you're going to take next year. But I got put on 3MI3 instead, which, you know, I'm really enjoying it, 3MI3, but, you know, yeah, the Tron guys need some love, you know. How many Tron courses do I teach? I teach just this one at the moment. Yeah, if you take a look at my title screen, 2 comp sci courses and a mechatronics course this semester. No, what you really want me for is 3TB4, which is the course on FPGA programming. If it hasn't been you know, moved away from FPGAs in the time since I last encountered it. But it's all up to the department, my friends. It's all up to the department. I would say, though, for purely cynical and self-interested reasons, that I would love to teach either 3TA4 or 3TB4 because they're 4-unit courses, which means I get 33% more money for teaching the course. So from a financial standpoint, I would love to be teaching all of these 4-unit courses with lab components. But anyway, we should get into the this. So, the next cup we have to kind of keep moving here. So, capitalist. Yeah, I do not apologize for being a scummy capitalist. Yeah, it's you know, a little bit of greed goes a long way. It's not good to be too greedy, but a little bit of greed is good. That's what I say. Mm. 1P13. Yeah, I don't know. Don't ask me. I don't have any idea what's going on in the first year program anymore. Like, they've got their own faculty for it now. I'm just gonna be content with staying inside CAS, where I know people don't seem to hate me, and, you know, etc., etc. Anyway, so this is an example that we don't need to dwell on too long. The point I'm trying to make here is that the address of operator, which is ampersand, and the pointer dereferencing operator, which is asterisk, only if they're sessionals. If you're, it's all the profs in 1P13 are now millionaires from one course. No, it's only if they're sessionals. If they're full-time staff, they're on salary, so it doesn't matter how many units they get. So essentially, you remember we have the address of operator. It's a prefix operator. When you apply it to a variable, you get the memory address of that variable. So the variable, of course, is a little box sitting in your memory, a box with the label on the side of it, and the address of operator allows us to read the label on the boxes. So, of course, the opposite operator, which is the dereferencing operator, is you are given a box label, and you find the box that label belongs to, right? So, if you combine the two of them, it actually does, like, nothing. If you extract the address and then you follow the address back to the original variable, the original memory cell, that doesn't actually do anything. It's like +1 -1, right? Or other arithmetic operators that are the inverse of each other. But yeah, so I just wanted to point that out. And also, you have to get the address, like if you're going to do this little inverse trick, you have to get the address first. Of course, although the dereferencing operator appears first, like if you're reading it left to right, remember binding, right? The address of operator will bind to the variable first, and then the dereferencing operator will be applied to the result of that calculation, So if you were to reverse the two, that wouldn't work, unless a was already a pointer. So a, if you dereference just some variable, you're going to try to open a box in the memory that doesn't belong to you, which results in a segmentation fault. So this guy causes a seg fault, whereas this guy does not. Make sense? Hopefully. I'm going to end this poll. Less than 50% of people are dead now. That's good. Yeah. As Andrew summarizes quite succinctly, ampersand gets the address, dereferencing the star gets the value. Yep. So, it can be easy to think of pointers as entirely symbolic, and forget that they too have concrete values in memory. Pointers may be collected and organized into arrays, just like any other data type. So you can actually have an array of pointers. In this particular example, we have a constant character array, but it's an array of pointers, right? So it's an array of character pointers. And as we know, because we're not dummies, we know we get computers and junk, we know that a character array is the same thing as a string. So we are initializing our constant character array, our constant character pointer array. We're initializing it with hearts, diamonds, clubs, and spades. So this is an interesting thing, right? Up to this point, with arrays, we've, generally speaking, had to deal with these things as if they were rectangular. But now, because our array contains pointers to other positions in memory, those other positions in memory can be of any length we want or require. So we can construct what you might call jagged edge arrays, which is kind of cool. If you were to visualize this in memory, it would look like this, right? Your initial array contains pointers to a bunch of other arrays. You could call these sub-arrays that contain all of the characters for all of the strings. And because we're not, like, the difference between this and declaring a two-dimensional array is a two-dimensional array would require you to declare it rectangularly, right? You would have to declare like a width of x and a height of y, and you would designate that block of memory, and it would be strictly rectangular. But because this is, because of pointers, we can actually have different sizes. I might be hammering this a little bit too hard. So, each element in the array is a pointer to a character array. The fact that our array contains pointers instead of character arrays themselves means the character array's memory is managed separately from the array of the pointers. Whereas a 2D array must be rectangular, each character array pointed to by the array of pointers may have a unique length. So there you go. What does the const do? It just means that it restricts write privileges. That's the best way to think of it. I'm assuming you guys have used you guys have used computers long enough to understand like write privileges on files, that you can lock a file so that it's read only, right? What the const modifier does is it locks something such that it's read only. So this array may not be modified past the point of its initial declaration. That's what that does. Good question. Thank you. So we're going to shift gears very slightly now, because we've seen these, we've seen pointers printed out, right? But we might not be able to interpret these strange numbers, these strange artifacts. So I will just, I will start a poll that says, do y'all know hexadecimal? Stop that, you. Get out of here. I think I broke it. There we go. Do you know hexadecimal? There we go. I have to say, I'm digging these low latency streams. So, most of you, well, okay. So like 1/3 of you know what a hexadecimal number is. Okay. We shall go through it, because there are a few, there's one that you might not have heard of. You clicked yes and it chose no. Strange. Okay. So, when we print a pointer, the memory address is formatted in hexadecimal. So we should probably talk about base systems. If you use int x equals 4 to initialize an array's size, it says it doesn't work because it's a variable size. But if I were to do a const int x equals 4, would I be able to initialize an array's size with it then? Yeah, I'm not a native speaker of hexadecimal, but I know what it is and how to translate. Well, that's all you really need to know. Yeah, so yeah, this guy will need to be static, and that's probably why earlier on when we were talking about arrays, we were using we were using macros to initialize the sizes of them. But anyway, let's talk about bases. All your base. Ha ha ha. That's an old meme. Do you guys remember the meme, all your base are belong to us? Possibly. So, in the binary system, you have 2 digits, 0 and 1. In the decimal system, you have 10 digits. You have 0 through 9. Binary is base 2, decimal is base 10. This is why they're called binary and decimal, because that's the number of digits you have in the number system. System Shock, right? No, it's not System Shock. It's an older, it's like a SNES game. An old one, but it checks out. So, the two that you probably haven't heard of are octal, which is base 8, and hexadecimal, which is base 16. Octal is easier to understand because the digits are simply 0 through 7. But hexadecimal, you have digits 0 through 15. So basically what you do is you start using letters as numbers when you get past 9. Zero Wing. Yeah, that's the game. Yeah. So A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So this is basically a way of representing numbers that are up to, 16 all in one character, which turns out to be very useful. So the reason that we do this, in computing, is when you write out numbers in decimal, you don't actually get a direct correspondence between the decimal number and the underlying bit representation. Everything's in binary, right? So one octal digit represents 3 binary digits, right? Because in binary, 7 is 111. Hexadecimal represents 4 binary digits. It goes because F, or 15, is 1111, right? So the reason that we use hexadecimal is as a more compact way of displaying binary information. The problem with decimal, of course, is you need 4 bits to represent one decimal digit, but you're wasting a bunch of space. Like, you've got, 6 slots for numbers that are being unused in like if you're doing decimal characters as numbers. So although decimal is very convenient for humans to read, hexadecimal is like closer to what the computer would speak if the computer could speak. So, converting from hexadecimal to decimal. The base system used by a numeric representation tells you the value of each place value in that number. So, if you had the... let me get rid of slack there for a moment. So if we had the number, what is this? 96,183,492. The reason that we can interpret this number correctly is, you know, you've got 9 multiplied by 10 to the 7, 6 multiplied by 10 to the 6, etc., 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 all the way on down the line. Question. So when you have something like 10, does it take up more bits than 9? No. Well, yes. So the thing we're working towards here is, like the thing that's implicit here. When you take a binary number and encode decimal digits in it directly, that's called binary coded decimal, right? So yeah, let me just get it for a moment. So in binary, right? 7 is 0, 1, 1, 1, 1, or sorry, 0, 1, 1, 1. 8 is 0. Is 1, 0, 0, 0. 9 is 1, 0, 0, 1. 10, and so the problem that you have here is if you're using decimal, if you're using binary directly to do decimal, that's as far as you can go, right? That gives you 9. However, so if you want to do a number like 10, the first digit is 0, right? The next digit is 1. So that gets coded in binary coded decimal to 1, 0, which is 10, right? However, in the binary system, you could just do, like, as a, in binary or hexadecimal, you could just do 1, 0, 1, 0. That's also equal to 10, right? But so you're wasting a bunch of space inside of your representations. Yeah. So it takes 4 more bits to represent the number 10. So it actually takes 8 bits to represent the number 10 in binary coded decimal, whereas in like straight binary, you only need 4 bits for that. And you can imagine that, like, as the number gets larger, the number of bits you're wasting just increases, right? But yeah, so that's the idea. So in if you were to take this same number and interpret it in terms of hexadecimal numbers, right? You would get 9 times 16 to the power of 7, 6 times 16 to the power of 6, etc., 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 all on down the line. And so, as a hexadecimal number, if you were to interpret this in decimal, you would get 2,518,186,722, which is a much larger number. You increase the density of the information by a factor of, what is it? A large amount. Factor of 100 at least, 200 maybe. So, encoding a decimal number in hexadecimal is much more complicated on paper than in a computer. If you are converting from decimal, each hexadecimal digit may be expressed as digit n is the number modulo 16 to the power of n divided by 16 to the n minus 1, where that is integer division and you're not concerned about the remainder. Like, you're not concerned about decimals. Where n is the place value, capital N is the number we are converting, and percent sign is the modulus operator. Y'all know about modulus, right? Did we talk about modulus? Did they talk about modulus? Anyway, so therefore, if the number is binary encoded, we can convert it to hexadecimal by considering each group of 4 bits a single digit. So, the first 16 integers in various bases. Yeah, okay, good. So, okay, good. I'm glad. Usually modulus, it's surprising how many people get through an intro programming course without knowing what modulus is. So, good. Yeah, that's seeing if a number is divisible by another. That's like one way to use it. You can use it a bunch of different ways. You can also use it to you can use it to convert a linearly increasing number into a periodic number as well, like a sawtooth. But anyway, so the first 16 integers in various bases. So you can see in decimal we have 0 through 15. These are the binary representations. Octal is interesting, right? So up to the 8th number, like the 8th number in octal is 07, so once you get above 7, you're now in, like, that looks like 10, but it's actually 8, right? Because it's 0, it's this number times 8 to the power of 0 plus this number times 8 to the power of 1, right? That's why it's called octal. So yeah, that's just a handy conversion chart for the first 16 numbers. So, in C, then. So how does all of this integrate with C? While writing a program, we need to tell the computer if our numbers are in hexadecimal or other base notations. So, are we going to do 2's complement and adding subtraction in binary? We do have a few... We have some of that coming up. I don't think we don't get quite as far as 2's... Well, I think we do 2's complement. It's later on though. It's like in the less we need to keep motoring so we can get there. So, in C, if you want to write a binary number, you prefix that literal with 0 and then either a capital or a lowercase b. So if you wanted to write a binary number directly in C, it's very easy. It's just 0b and then the binary number. If you wanted to do octal, you prefix it with an O. Oh wait, I'm sorry, that's not a 0. Is it a 0? It's difficult to tell. Let's see here. Sounds good, sorry, just worrying. Yeah, don't worry about it. Don't worry about it until we get there. So, yeah. So, let me just, like, assign an integer here. So it's also important to understand that, like, while we're talking about all of these different base systems, they're all still integers, right? So 0b 0001111. There we go. Will it compile? The question of our lives. There we go. GCC topic 6.c. Conflicting data types. Uh-oh, I declared X twice. Let me fix that. Z. There we go. Yeah, so there you go. So this is a 0. If we want to do octal, int O is equal to 07 or 77. There we go. That'll do. Why does it keep flipping? Stop flipping. There. Oh, so it is 0. Okay, it is 0. There we go. I don't know why I didn't trust the slides there. Presumably, I looked it up before I wrote it on the slide. But okay. So yeah, octal is you just prefix 0 for some reason. Probably just a legacy thing. So with decimal, you started off with any digit except 0. And with hexadecimal, you started off with 0x, upper or lower case. Hexadecimal allows us to express numbers much more compactly than binary, while maintaining a straightforward relationship to the underlying memory representation. So it's like, you know, if you're concerned about the arrangements of the particular bits in memory, you're probably going to be looking at hexadecimal. The other thing is that, like, it makes the numbers always the same size if it's in hexadecimal, you know? Like a pointer would vary widely in its size. Yeah. Question, do I speak Russian? Yeah, my keyboard has been flipping back and forth. No, I don't. I've been learning it actually as a fun thing to do with my spare time that I don't have. So, someone add it to the Wikipedia page. I don't know. What? So, proud and practical pointer passing. All arguments are passed by value in C, unless the value you pass is a memory address. Although, strictly speaking, a memory address is still a value, but it's like passing by reference because you are literally passing the value of a reference, right? How did you get that hexadecimal number again? 0x. Passing by reference allows functions to modify the referred data in the calling function. This can occasionally be useful. This, for example, is how and why, what is it called? Get string, no, it's, oh, what's it called? Gets, or whatever it is, the other one, the one that reads standard input. I forget what it's called. Anyway, so in this particular function, we're passing the address of the variable foo, but bar is already a memory address. What? Yeah, bar is already a memory address because it's a bar is already a memory address because it's a an array. No, I've been doing like the language game app on my phone, but I thought, you know, might be useful. So I like downloaded a keyboard and you know, so I can type in Cyrillic now. Wow. Every time I think I'm in one mode, I'm in the other, which is kind of cool. It was just flipping back and forth. Anyway, we use the address of operator ampersand to pass the address of foo, but bar is already a memory address. In C, an array is equal to, like defined as, the address of that array, the first element of that array. So in C, an array, when you say bar without including the square braces, what you are saying is this is the address of the first element of the array. Um, yeah. Oh, yeah, yeah. If you need to convert hexadecimal back and forth, you can get your calculator to do it. Oh, it's kind of interesting, actually. There's a bit of a story behind foo and bar. So, nobody is quite sure what the origins of foo and bar are as variable names for teaching specifically. Like, it's only in tutorials that you'll see foo and bar used. But my understanding is that when one of the early people who put together one of the earliest working computers, when they were cleaning out his house after he died, there was a model train set in his basement, and some of the switches on the model train set were labeled foo and bar. So that's one apocryphal story of the possible origin of the terms foo and bar. The other one is that it's a reference to the military slang foobar, which is an acronym which stands for effed up beyond all reason. So it's possible that foobar is a reference to that, which at the time that the first computers were being developed, military slang would have been still very prominent in the culture, because we had we were either in the process of or just getting over beaten the Nazis in the Second World War. So yeah. Yeah. Yeah, it's fun, right? Computers, there's this whole deep culture of computers that you don't even know is there, and it's my duty as a professor to sort of tell these apocryphal stories and keep the culture alive. But anyway, when you have an array, just the identifier, that is C knows that as the array of the first, or the address of the first element of the array. So when we're inside of this function, foo will need to be dereferenced, but bar will not. So here's an example, cube by reference. We have a function, cube by reference. It takes a integer pointer, end pointer, and to the dereferenced pointer, it stores that pointer being multiplied by itself 3 times, right? And I know this is a lot of stars, but remember, this is a dereferencing operator, right? So it's kind of interesting. In order to write to a memory address that you have a pointer for, you have to dereference it on the left side of the equal sign here. So the result of this will be, well, actually, you know what? It might be cool to do this in Python Tutor, the C mode. So let's write our anytime I see this blue blocko vision, I'm kind of you know what, this was probably better done in Python Tutor. So void, gotta put it at the top, C B R takes int prompt int end pointer, dereferenced end pointer is equal to dereferenced end pointer times dereferenced end pointer times dereferenced end pointer. Someone was asking me if pointer dereferencing is a destructive operation. And this should prove that it's not. So if I say int number is equal to 6, for example, and I call CBR on num, on the address of num, that is to say, then print the result, you'll see what we get. Oh, print F. I'm doing too much Python lately. There we go. Python tutor carried me through A2, made debugging my algorithms so much easier. Yes, so if you're not using Python tutor already, use it. What is CBR? Oh, that's just abbreviated cube by reference. I just didn't want to type cube by reference out. Cube by referencing by dereferencing. Yes, exactly. I know you like Python tutor, but versus VS Code breakpoints are a great visualization of the call and heap stack. Plus, it has great variable values. Stop trying to get me to use VS Code. You people and your frigging campaigns, man. All right, so we start up our program. Num gets the value 6. We then call CBR. So we call CBR. We have a pointer here, right? That pointer gets initialized. It points to num. Why did I... That shouldn't be. There we go. So the pointer points to num. It then puts the value back into num, right? This might be more clear if we declared some, like, intermediate values, but yeah, so it cubes it, puts it back into the original spot, and then closes itself. So you don't notice that we are able to return, we're able to put a value, calculate a value, and store a value in the main function's stack frame without having to return it, right? Generally speaking, this is not the preferred way of doing things. Normally, like, I would rarely, if ever, ask you to do this on a test or an assignment or something, unless I was specifically wanting you to, like, use pointer manipulation. Because, like, generally speaking, it's best practice to use return statements for this type of thing. But, you know, you can think of this as how things were done before return values were a thing, right? Before the concept of a return statement was developed, this is the way that you would have returned values. Yeah, it does. Yeah, C tutor does have its limitations, obviously, but you know, it is what it is. It's still a really good tool, despite its limitations, especially for pointer visualizations. I don't want you to use GoTo, not unless you want to get attacked by raptors. So, like the C tutor. This C tutor thing will be especially useful because it puts the arrows in where you have pointers. Like, that's a very key mental concept, and it's really good that that C tutor does it so nicely. So that's for that alone, I would recommend using C tutor for you know, anything to do with pointers if you want to visualize it. So yeah. In order to accept memory addresses as an argument, the fact must be specified. That fact must be specified in the argument's type information. In this example, we replace the following operations with so operations that we don't have to do is passing number by value to cube by reference, computing the cube and returning it to main using a return statement, and then assigning the return value of cube by reference to num. We're replacing all three of these operations with passing the address of num to cube by reference, computing the cube, and storing it directly in the memory address that we have been given. Stylistically, pass-by value is preferred unless the situation explicitly calls for pass-by reference. Passing by reference in this way violates the principle of least privilege. Yeah. So I want to talk just very briefly about the principle of least privilege. The principle of least privilege is a sort of a organizational doctrine in software engineering. The idea is that nothing should have more access than it needs to perform its task, right? So this applies to programs and it applies to users. This is the reason that in order to install a program, you have to give yourself administrator privileges temporarily. Because if you had administrative privileges all the time, if a virus was on your computer and was behaving, acting like you in the background, it would have the ability to do way more damage than it is normally able to do because it has that sort of heightened level of privilege. So this applies to programs as well. When I write a program, it's good practice to not give that program any more access to information than it needs to perform its task. This is one of the reasons why we use Const. We can actually lock, for example, the arguments that are given to a function so that the function can't modify those arguments because that might have unintended consequences. But that's a very general. That's like a security feature. A lot of the security that exists inside of, websites or computer systems or anything like that, governments, spies during the war operated on the principle of least privilege. It's like, I could tell you, but I'd have to kill you, sort of thing. It's like, I have received a communication from Agent X, and it's like, you're not allowed to know the identity of Agent X, because if you were ever captured by the Germans, they could torture you and get the name of Agent X, and then Agent X would be compromised, and you don't know where, Agent X might be your next door neighbor, or they could be, someone on the front line in enemy territory. You don't know, because you don't need to know, because it's a security risk if you know things you don't need to know, right? Yeah, it is. Principle of least privilege is like need to know basis. It's like the computer version of a need to know basis. Yes, absolutely. But yeah, or it's like need to know is like read privileges on that level. It's like if you applied that concept to writing privileges, then that's where we are at. Because normally with computers, read access is usually not restricted nearly to the degree as write access. But anyway, so that is our class for today. Are there any questions? You don't know because you don't need to know, Yeah. Exactly. Yeah, so with passing by reference, it gives the function more access than it needs, so that's why we prefer to use the standard interface, which is function arguments and return values. Return values are mediated by the operating system, whereas using pointers directly, that's just you, baby. That being said, there are some languages that use pass by reference as their default passing scheme. I believe Java does that. But, yeah. I like how this class relatively makes sense compared to everything else. Thank you. Because, it's definitely possible to teach this material in a way that doesn't make sense. I like to think of it as like, you know, I might be at least a little bit good at my job if my students are like, oh yeah, this makes sense. The trick is teaching like a really hard course and still have the students say, oh yeah, this isn't too bad. Hopefully you're still saying that when I give you the test. And hopefully I can teach you something useful at the same time as it making sense. Cool. Well, if there are no further questions, I'll be logging off here. I have my office hours on campus today, so if you have a question and you'd like it answered, I am available this afternoon for that sort of thing. So drop on by. But I'll also be doing it digitally, so if you want to have a digital like a Zoom call meeting type thing, just send me a message on Teams and we'll get hooked up with that too. Cool. All right. Take her easy, folks. And if I don't hear from you this afternoon, I'll see you next week. I think. Yeah. Yeah, really. Yeah, we need to get a move on with this material. When are my office hours? 1:30 to 3:30. ITB 102. Information should be in the syllabus. I don't know why I was like looking at the power button. Anyway, take her easy, folks.